All right, you guys, welcome back. Today it's a little different. I have an Audi. My nephew's Audi, to be exact, with a check engine light. Can't pass smog. It's unfortunate we have to smog in our county. But today we're doing a diagnostic video. Before I get started with diagnostics, there's one thing I really enjoy doing, and that's cracking open a cold one. So forgive me if I'm going to be drinking on set today. Make sure I get my Alani, get me all ramped up. Either way, welcome to TheoryWorks. So, my nephew went to the zone and had them scan the car. We've got a few faults. Looks like we have a P2019 intake manifold runner position fault, a secondary error fault, bank 1 and bank 2, so that's not good. Evap and that's all of it. Bank 1 and bank 2 secondary air injection, evap fault, and intake manifold runner. Frankly, I'm not super concerned about the evap fault yet, but let's talk about why. So the hardest part of working on cars is diagnosing cars. For instance, sure, there's repairs that are difficult to do, changing water pumps, especially if you're unfamiliar, but really being able to track down the root of a problem really makes you exercise your mind just a bit more. And so, for instance, our car here has got multiple faults, and sometimes it's tough to decide, well, which faults are the important ones? Because, to be fair, there is some faults, we'll call them ghost codes, that show up in the background of an ECM, but don't necessarily trip a check engine light. They're more informational towards potentially the root cause. So we have intake manifold, runner position sensor, and secondary air injection system. So one of the things I do know about, this is a 2015 Q7 with a 3.0T supercharged. Don't confuse that with the turbo. So a common issue with secondary air ports is they can clog up on a 3-liter. So maybe that's a separate issue. But the secondary air ports are vacuum controlled. Also, the intake manifold runner is vacuum controlled. So maybe, just maybe, there's a correlation. Let's find out. Let's see what's under this bad boy. Whoa, it is hot. Whew. Almost like somebody's been driving it. Let's see, 219 intake manifold, 219, double fault there. So 491 and 492. I'm hoping that maybe there's a correlation and we have a vacuum leak. Let's take a look. The beginning is what you have to use to try to get to the end. But sometimes starting is the most difficult part of a project. Where do you determine where you want to go? Electrical tests, vacuum tests. What's your options? What's hard is if you look on the forums, you're going to find a lot of information. Some good, some bad. But that can be really difficult to be able to kind of go through if you're not experienced with what information is not great. But let's see what we have. So I think, let's say? I can't even remember. I'm getting old. Okay, bank 2 on an Audi. Bank 2 is driver's side. Right here. And we can actually see the sensor, luckily, on this side. And the nice thing is the intake runners are under the supercharger. They're vacuum controlled. So maybe we have a vacuum leak. Let's find out. All right, so you can see on bank 2 where there's some etching done on the front, which is where they've removed most likely the factory logo. So that means that we already have an intake runner that's been replaced on this side, which is curious. All right, so you can see on bank 1, also our part with the white ring, here's a position sensor bank 1. And see how we have the Audi logo in there and all these part numbers? That one is most likely original. All right, now that I've refreshed with the cold one, when you're diagnosing your car, you have to look, listen, and feel to everything that's going on. So for instance, a new clue we have is that's already been replaced. So now that goes into that adds another realm of possibilities of, was it a bad part out of the box? Was it incorrectly installed? Which can happen on this car. Maybe we have a vacuum leak, or maybe we just have a bum part. But next step is we're gonna hook up a scanner. Let's get some scan data, because the nice thing on a V6, because we have one there and one there, we can compare values. And that would be super helpful right now. Let's get that scanner installed. Let's get our Trent handy dandy Matco scanner involved here. Maybe it's going to unlock the clues to why this car is clueless. Let's see what we have for options here. All right, Matco, don't let me down. Key on so I can start looking at some data. That there's no keys in the car. I'm gonna go get some keys. Don't you stop recording. I'm getting some keys. Can't believe there's no keys in this car. It is, I found them. Definitely makes the car way easier to work on when we have keys. I don't want to start it because I just want to look at some data. After I figure out what I'm doing. Oh. AC's kicking. Okay, let's turn that off. Lights are on. That's fine. Let's go down there. Okay. Radio's going. Don't need that. Processing. Yes. Yep. Just hit OK there. All right. Let's see. DTCs. Let's take a look to see if it matches. Ooh, also have PCV regular valve performance. There's our evap leak, not worried about that. But this 2019 is what we're gonna focus on here. Okay, so let's go out. We don't want to clear the faults. Let's find some data. Read by list, because I don't know what channel I need. Take manifold pressure. There's a lot of, oops. Gloves making it tough. All kinds of stuff that I don't know what it's supposed to do, but there's information in here. Oh, here we go. Runner flap, bank 1 position. Actual, bank 1 specified. You know, we'll do a specified. Okay, so we also want bank 2 actual and a bank 2 specified because we're comparing to both of those. All right, let's take a look, see what it says, and a bunch of zeros, I don't know. Okay, it just says 100%. Let's do some actuations. Next step, now that we finally found our live data, what felt like 30 minutes later, at the very bottom. So you can see here, we have our actual value versus our specified values for bank 1 and bank 2. Currently, the car is specifying 100%. So what I'm going to do is I'm going to manually activate them and with my fingers and see if those values actually change to see if the sensor is failed or if we have an actuation issue. So what I'm going to do is I'm going to try to determine if we have so the fault says sensor switch issue. But what's confusing is they're not identifying, is it a actuation issue or is it the sensor isn't picking up the sweep of the flaps operating? That's the part we're trying to determine. why the car is bad. So let's see here. I'm gonna take this guy here and make some things move. Hold tight, Mr. Customer. I'm going to push on the sensor because they're vacuum operated. And I can see it right here in the front. Let's see if I can get my finger in there. And see, I actuated it, went to 0% manually with my finger. I let go, it's 100%. Okay, so we have at least that one operating. This one, oh crikey, there's not enough space in there to get my fingers. Oh no! We have a communication warning. Oh, there's an error. Oh. Took me like 30 minutes to find that sensor feed. It's okay, we'll do it again, it's fine. I know it's at the very bottom this time. Let's try it again. Okay, let's see, data stream, check. By list, yep, we'll do that. It was like 142, I think. If my mind is working correctly. There it is. Let's see. I don't care about spec, honestly. I just want to see actual. There's bank 2 actual, bank 1 actual. Those are the only 2 I care about. All right, back to business. Let's get this thing adjusted. Not adjusted. I'm just trying to test it. Okay, we have 100%. I'm going to carefully manually swing the sensor. 0. So that tells me that currently we don't have an electrical issue with the sensor itself, but most likely we have a control issue. And that's what the computer's picking up. How is this controlled, you might ask? Good question, I don't know either. No, I'm just kidding, I do. It's vacuum controlled. Let's check the vacuum circuit. When you're diagnosing a car, we talked about look, listening, and feeling your surroundings, really becoming one with the project. You know, this is tough because I have an idea what I want to do, and I normally do this quietly, but I'm trying to tell all of you guys how to do it. So forgive me if my words are slow, but they may be slow. I don't know what else to say. Either way, so we determined not a wiring issue, but probably a control issue, vacuum control issue. So there's a solenoid. There's one solenoid that controls 2 of these guys. Where's that solenoid? It's back there. Let's move some of this stuff out of the way. So pull that guy off. Audi. Back here, we have 2 solenoids. One of these is secondary air, and the other one is for our intake runner flaps. So you got to remember, when manufacturers build cars, everything they're designing in a car is built with a purpose. And so there's not that many times where you can look at a car and be like, why did they route that way? That's odd. This is something here noticeable where, ouch! God, that was hot. Only like 200 degrees, it's fine. I'll set some of my little arms. Anyways, so we'll bring the camera in a little closer. But right here, you can see that this vacuum line is looped underneath this vacuum line here, and they're rubbing. The manufacturer wouldn't do that on purpose. So that leads me to believe, is there a mismatch in the location of these vacuum lines maybe? That might be something I should look into. So right here, they have a common vacuum source. And then this is the outputs right here. But it doesn't look natural. So that's curious. Let's investigate some more. After I get down from this motor that is sweating me out, it is just radiating right here in my face. I gotta get down, it's too hot up here. So what I'm going to do is I'm going to try to determine which one of these vacuum lines goes where. Because is it that I'm working on I don't know if this black solenoid is secondary air or if it's the intake flaps or the gray one is. But what I can see is some of these things kind of seem like they're in funny positions, and that's odd to me. But what I'm going to do next is I'm going to use a vacuum pump on the output of the solenoid to make sure the vacuum circuit is tight, leading to our runners. Good news, Temu got a vacuum pump for me. It's like $9.99. It's super cheap. Does it work? I don't know. Could it? Maybe. Let's see here. No problem. Temu coming in clutch. Let's see. Ouch! Ah! Don't touch the engine. It's hot. It's hot. And where's my screwdriver? There it is. So let's take this one off. So I think this one is the one leading to my runners. Looks like, judging by the direction. I'm going to put my vacuum pumpa on there. Pumpa de vacuum. That's partially Spanish for vacuum pump. Oh, we have a size discrepancy. Oh, no, we're good. It stretched. It did not stretch. It's hot. Everything's hot. Everything's hot. My recommendation to everybody watching, I would do this on a cold engine because it is hot. All right. I don't know if you guys can see my vacuum gauge here. Let's apply some vacuum. All right. Most engines make 15 inches of vacuum. This one's holding vacuum, so that's good. Let's see if our runners have moved while I'm sweating. Okay. So the nice thing is there's arms with vacuum pots. I can see this one is pulled all the way in. And I can see this one's pulled all the way in also. And when I release it, I should be able to physically, with a pH, see it move. And it did. So that's good. So next what I'm going to do is I'm going to check a vacuum diagram to make sure the solenoid I'm working on is actually the correct solenoid. Oh, actually I got a better idea. While I'm here, we should check source vacuum. Well, Rick, what is source vacuum? It's what it sounds like. It's vacuum from the source, which is the engine and a vacuum pump in this case. Let's see what we find. So, let's see, source vacuum. I'm going to unplug the top of the solenoid here. Ooh, I heard a tiny bit. Let's plug this guy in. And, okay, so the one downside about my Temu purchase is it's got a big male end going into a tiny hose. Oh, I tore my glove. It's probably from the extreme engine heat. It's okay, I hope my screwdriver doesn't melt. All right, so you can see we have our needle down here. So now what we're going to do is with the engine running, we're going to see how much vacuum the engine's making to make sure our source vacuum is correct. But because I'm stuck in the engine compartment, I'm going to need my trusty dandy assistant to give me an engine fire. I'm also going to make sure that my hands are not located within the belt area. I'm safe on top of the motor. And I'm ready when he is. Ready, go. And we're moving. All right. Woo! That's pretty solid. We've got, I don't know if you guys can see it, but about 24, 25 inches of vacuum. All right, go ahead and shut it off. Thanks to my handy-dandy assistant, he shut it down for me. Also, there's a one-way check valve in the vacuum circuit, and you can see that the engine is not running. We're holding vacuum. I don't know if you guys are able to pick up that the gauge is over there, but that's a good sign. So source vacuum, non-issue. All right, now Eeny, meeny, miny, mo. Which one does secondary air injection? It's time to get in the service manual and check. Which the good news about that is the service manual's not in this engine. So I don't have to be hot anymore. I'm going to go where it's got air conditioning and look up some information. Come with me, guys. Sometimes you work on cars and it makes it feel like you don't know what you're doing. And you have to sit back and think about that. And then you realize you don't have to know everything. You just have to know where to find the information to know what you need to know. So in this case, what I need to know that I don't know is these two solenoids back here. What does what? The irritating part is, let's get some light in this situation. Those two solenoids. I looked at a vacuum diagram for this car, and the diagram showed 3. Different model. This car only has 2. So then I looked up a wiring diagram, and these are correct. The gray one goes to the intake flaps. Black one goes to second air injection. So that's not ideal. But let's run a vacuum self-test on the intake manifold flaps and see if the problem is still there. All right, now we got this beast fired up. So my plan now is, the nice thing about Volkswagen products, Audi products, is for a lot of the engine modules, you can run self-tests to see if the problem exists, see if maybe you fix the problem. You can't do that on all cars. But I'm not actually super familiar with using the scan tool to do that. So I guess we're going to have to figure that one out. Oh, basic settings, all right. Read by list, yep. Oh, here we go. Intake runner flap adaptation bank 2, intake manifold flap adaptation bank 1. Let's get a little closer and see what we're doing. All right, so let's do bank 1 first. We'll click on that. You can see we have our actual specified adaptations okay. Actually, we gotta clear faults first. I forgot about that one. Oops, moved too fast. It's okay. We'll go here, say clear faults. Yes. No fault codes, perfect. Sometimes the cars get angry if you do it while running. It'll be okay. All right, now we'll go back. Basic settings, check. By list, yep. List set, okay, here's the bank 1. All right, let's... Oh, my options are adjust or help. Pretty sure adjust is the one I want. So we'll hit that. It says adaptations running. We can see flap is actuated. The numbers did things, and it says it's okay. Let's do the other one. All right, let's see. Now, moment of truth. Bank 2. That's the one we had our fault for. Okie dokie. And apparently adjust means go in the scanner. Okay, see, went to 0. Things are happening. Adaption okay. We just ran the intake manifold flap adaptation bank 1 and bank 2. They both passed, even though we had a check engine light for a bank 2 issue. You might wonder, well, Rick, why is the check engine light on then if it just passed its test? I don't know. But what I do know is there's not currently a problem. So that means that we're dealing with an intermittent issue currently, which is hard because when you try to duplicate an intermittent issue, you can't test under all circumstances. So for instance, let's just say this problem is intermittent 25% of the time. 75% of the time, when you test it, you're not going to find a problem. So what do? Now you have to start doing deductive reasoning. Okay, could our vacuum circuit be intermittent? Not likely. Could that aftermarket intake manifold runner be intermittent? Sure. I mean, it's a potentiometer inside where it's checking the voltage as the manifold is adjusting. So that's an option for intermittent. The other reason why I'm not going towards vacuum and I'm not going towards the solenoid is because the vacuum and the solenoid, those sources both operate bank 1. Okay? Bank 1 never threw a fault. So deductive reasoning says it's not the vacuum source, because if it was an intermittent vacuum source, we would have a bank 1 fault. It's not the solenoid, because one solenoid controls 2 runners. So both runners were not throwing a fault. So solenoid is out of the question. What does that leave? ECM, because the sensor goes directly to ECM. Wiring between the sensor and ECM? The sensor. Well, ECM's not overly common. The wiring to the sensor? Sure, it could happen. But a failed potentiometer is more likely. So unfortunately, because you can't duplicate it, now you have to use deductive reasoning to guess on what the problem is. So the next valid step is you could take the wiring and open up the loom, kind of inspect it. But realistically, when you have an aftermarket sensor on a car, my experience is that's usually the cause. And while I was up there, you guys didn't really see this, but I was wiggling the wiring, trying to see if it was going to cause any issues. Nothing really happened. So it's probably just that sensor being angry. Oh well. Now what? I don't know yet. But I'm going to go take a drink of my drink and think about it for a hot second. There's a concern that maybe we have a wiring issue with that sensor, which is an option because we know that the supercharger has been removed from this car. Somebody's already tried to fix this. Oh, you know what? Oh, crikey, I found another clue. And all I did was talk out loud and talk to you. Little did I know it, but I might be a poet. Because the one thing I see that I didn't pick up on earlier was somebody has changed the sensor and not the actual intake manifold flaps. We should change the flaps because what can happen is the shaft can wear for the flaps. So the intake manifold flaps, they go right here, one on each side. And I don't know what they do, but they do air tumbling thingies. So flap opens, long runners, high flow, flap closes, maybe high velocity. I don't know, sounds like science stuff. I just fix cars. That shows me somebody was trying to maybe find this problem because they only replace the sensor, which in the professional world, I would never replace just the sensor. I would always replace the whole runner. As that shaft that's operating the flappers that go like this can wear and it can hang. And I bet you that is what's causing the problem, is every now and again, it's probably hanging in either a closed or open position because of wear. And the computer's sensing that and it can't correct it, so it trips the fault. Because on this one self-test, it did pass. So deductive reasoning says we're replacing bank 2 intake manifold runner assembly on a different day because this engine is hot and that job is hard. And we don't have any parts. Thanks, guys. Remember, for more questions, comments, or concerns, thanks for watching Theory Works, guys. And that's the theory of an intake manifold runner. I know I said it was done. I changed my mind. I was I was thinking, and then I was looking at it, and my nephew brought up a good idea that what if it's a loose connection? I thought, that's a possibility. Like we talked about, trying to diagnose a car is look, listening, and feel, and really paying attention to everything you're seeing, how minute the details are. We may have found a loose connection. Right there, that little gray tongue that's sticking out of the connector, right north of it is a little black tongue that is not on. So I bet if I were to push, it would probably come loose. Okay, I'm just kidding. It's not coming loose. But I'm going to release this. Let's see if I can release this connector. Oh, maybe not. Come on. Okay. And now let me see if I can plug it in just a little bit more. Does not want to fit well right there. I just found something. Once again, Sherlock Johnson. So I undid. See, get my flashlight. And I was trying to push it up and it wouldn't clip in. And I see something inside that connector that is interfering with us. So what I see is there's a seal in here that isn't in a great spot. There's a white weather seal around that connector on the inside there. And that's there to keep moisture and whatnot. And that guy is holding up us getting in there. So we're going to put some lubrication on that guy. All right. Here we use our screwdriver to try to get it in a close position. I literally cannot get this to clip back in. I've wrecked the car. The car's broken. I need to do something else apparently. What's going on here? So, I think I've got it attached now. We'll get another close-up shot here in a second. Let's get a closer look so you guys can see it for yourself. Alrighty then. It's always nice when you can fix a car without buying parts. Parts are expensive. Who wants to spend money on repair components when you can spend money on, performance upgrades? But either way, I'm glad we figured out. I'm feeling pretty confident that was the reason why we had an intermittent bank 2 runner problem. And got my screwdriver back. Landed in the belly pan. Darn Audis. So there we go. P2019 bank 2. Hopefully I gave you guys enough information that you can solve that on your own car. 3.0T supercharged. Thanks guys. Love you tons. Theory works. Catch you later.